Section 2-8, two-variable inequalities. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. The lines can either be dashed or solid. The half plane is the region of the graph where the shading occurs. Now, for a line to be dashed, it is either going to be greater than or less than, and for a line to be solid, it's going to be greater than or equal to, or less than or equal to. Our first example we are going to look at is how to graph linear inequalities. So we have y is greater than or equal to negative 2x plus 1. Hopefully you guys recognize this equation. It's in slope-intercept form. This greater than or equal to is going to make my line a solid line. So let's start by graphing the boundary. So put a dot at positive 1, go down 2, and to the right 1. And again, since it's greater than or equal to, you're going to make this line a solid line. Now we need to shade our graph. So we're looking for the region of this graph where y is greater than, and everything above your line is going to be greater than. You can also take a test point and plug in a test point to see if you shade that side or a different side. So it's always nice to use the point 0, 0 as your test point. Unless, of course, your line goes through your origin, then that would not be a good test point. So if you plugged in 0 for y, and you plugged in 0 for x, let's see what this gives us. So negative 2 times 0 is 0, plus 1 gives me 1. Is 0 greater than or equal to 1? That is never true, so you're going to shade the opposite side of the graph where 0 does not fall into. The test point isn't necessary, but if you want to check to make sure that you shaded the correct region, you can go ahead and use the test point to verify it. In example 2, I want you to press pause, and I want you to graph this inequality. So hopefully when you went to graph this inequality, you noticed that it wasn't in slope-intercept form, so we need to take a second and put it in slope-intercept form so that we can easily graph our line. So I'm going to add x to both sides, which gives me 2y is less than x minus 6. And then to get rid of that 2 in front of our y, we divide everything by 2. So that gives me y is less than 1/2 x minus 3. Okay, so again, it's in slope-intercept form, mx plus b. It's just less than, so this time we are going to have a dashed line as our boundary. Okay, so let's put a dot at negative 3 on our y-axis, and then we go up 1 and to the right 2, and instead of drawing a solid line in between those 2 points, you are going to make it a dashed line. Now we are looking for the portion of the graph where y is going to be less than, and hopefully you notice that is going to be below our line, so we're going to shade everything below the line. Example 3, we're going to move on to graphing absolute value inequalities. So no longer are they just line, they can also be our absolute value graphs, which look like a V. So we have y minus 4 is greater than or equal to 2 times the absolute value of x minus 1. So hopefully you notice that this is not in our general form right now that we learned in section 2.7. So to get it in general form, all we're going to do is we're going to take the 4, we're going to add it on to the end. So that gives me y is greater than or equal to 2 times the absolute value of x minus 1 plus 4. So from section 2.7 you would know that 2 is a vertical stretch. Remember, it's also going to be the slope of your lines. The minus 1 inside your absolute value bars is going to make your graph move to the right 1, and that plus 4 at the end is going to move your graph up 4. So that's going to make my vertex at 1, 4. So let's go ahead and let's graph that point. And then my slope is 2, so I'm going to go up 2 and to the right 1. I'm also going to go up 2 and to the left 1. I'm going to do that one more time just to make sure I have my consistent V, so go up 2 again, this time to the right 1, up 2, to the left 1. Now, look at the inequality that was given to you. It's greater than or equal to, which means I get to make my V a solid V. Now we need to do our shading, so we're looking for the portion of our graph where our y values are going to be greater than that, and hopefully you can realize that it's going to be right here in the middle, so we are going to shade everything inside our V. In example 4, it's a you try problem, so everybody press pause, and I want you to draw the graph for y plus 2 is less than negative times the absolute value of x plus 3. Again, I hope you realize that your equation was not written in its general form, so let's make it. So we're going to subtract 2 from both sides. Now let's identify all of our shifts that are taking place. So the negative is going to reflect it across your x-axis. The plus 3 is going to move my graph to the left 3. The minus 2 is going to move my graph down 2. So that puts our vertex, since it was moved to the left and down, at negative 3, negative 2. So let's go ahead and let's start by graphing that. Now the slope of my line is negative 1, so I'm going to go down 1 and to the right 1 and down 1 and to the left 1, and we're going to do that one more time. So go down 1 and to the right 1, down 1 and to the left 1. Now notice the equation that was given to you was just less than, so when you go ahead to connect your dots, make sure you have a dashed V. Now you're looking for the part of the graph to shade in where y is going to be less than, so that is going to be everything below your absolute value bars. In example 5, we are going to go from writing an inequality from a graph that is given to us. So in example 5, we have an absolute value graph. I know it's an absolute value graph because my graph is a V, so I'm going to use my general form y equals a times the absolute value of x plus or minus h, and then plus or minus k. So the first thing that's going to be very helpful when we're doing this is identifying your vertex. So the vertex is at 2, 1. So 2 is my h value, 1 is my k value. Now to determine a, we need to find the slope of our line. So the slope, I went up 2 and to the right 1, so it looks like our a value is going to be positive 2. And then the last thing that's going to change is our equal sign, since we are graphing an inequality. And I guess I should have shaded part of the graph, so let me add the shading so that therefore we can make it an inequality. So let's plug in a, h, and k and go from there. So that's going to give me y2 absolute value of x minus 2 because it was moved to the right, and then since it was moved up it was going to be plus 1. So now since it's a solid V, I know that it's going to be equal to. Now we just have to determine if it's greater than or less than. And if you notice, the shading is happening below your absolute value graph, so therefore it is going to be less than or equal to, and that's your inequality from the graph that was given to you. Your last example is example 6. I want you to press pause and I want you to write the inequality from the graph that is given. In example 6, I hope you notice that you are given a line instead of an absolute value graph. So now we're going to be using the equation y equals mx plus b. So b is the y-intercept, so where does the graph go through the y-axis? And I notice that it goes through at positive 2. Now let's count the slope in between those 2 points. So it looks like I'm going down 3 and to the right 2. So since I went down, it's going to be negative 3/2. Now since I have a dashed line, I know that it's either going to be greater than or less than, not equal to. Equal to would have to be a solid line. And if you look, the pink region that is shaded is above your line, so my actual inequality is going to be y is greater than negative 3/2 x plus 2.